All of you are welcome to my next lecture presentation, and that is the corrosion protection against the. So, what are the meaning of the corrosion, and which are supposed to be undergo the rusting, the destruction, whatever the material, that particular material can be protected, and those are the protective measures. So, with the help of different protection, we can safe materials can be there. All of you are well known about the metals and alloys, and one of the simple one is the iron. So iron undergo the process of the rusting. When we see the whole earth elemental composition of the earth, then we have the oxygen, the iron, okay, the silicon, and the aluminum. So major four elements comprise certain mostly these four elements are there. So iron itself undergo the process of the rusting. So what happen in case of the rusting? That particular rusting is because of the environmental condition. And what are those environmental conditions? We can see in presence of moisture that is present in the environment, and oxygen. Oxygen is also one of the main ingredients of the air. So in presence of air and moisture, iron undergo the process of the rusting, and that process of the rusting, that is then the product itself is there. So there certain iron oxides are obtained. So iron oxides are the, what are those? Iron oxides are the corrosion product of that particular. So corrosion itself, we can say the destruction of the material. Whatever the destruction, loss of the material. How we can get the loss? And basically the chemistry is also there, and that chemistry is involvement of the oxidation. Oxidation. What is the oxidation of the metals? What is the oxidation of material? What is the oxidation of food we are eating? So food undergo the process of the oxidation. That is the deterioration. How deteriorated? If we suppose we have the fresh food and that is kept in openly, then certainly oxygen attacks. In presence of oxygen, certain bacteria evolve, and that particular food is deteriorated by oxygen. So that is the oxygen. So similarly here, the corrosion itself also is the oxidation. Reduction, that is the reverse reaction. So here corrosion, we can define the corrosion as a very simple way, and that simple way itself is, you can say, the destruction, deterioration, decay of the material. Many of the examples available. What are those examples? Different metals. We can see the periodic table where number of metals are there, starting from the alkali metals, then alkaline earth metal. All of you can see the periodic table that was also discussed in my lecture in the periodic table, and in the electronic configuration of different elements. So here, why destruction? Why deterioration? Why decay of the material? And how we can protect that particular destruction of material? Why destruction occurs? Because of something reaction may be there. And what are the reaction responsible? Which reactions are responsible for that? Which one? Certainly, chemical reactions are there. The chemistry is involved, and what is the basic chemistry? I have discussed the oxidation. And what do you mean by the oxidation of elements, of the metals? All of you are well known about the iron. So iron having the different oxidation states. So what happened? Iron. Iron without any positive charge, iron itself the zero, and that undergo the process of the oxidation into the Fe plus 2. So Fe plus 2 itself is the oxidation of iron. In the sense of the electronation, electrons are added or removed. So oxidation is the removal of electrons. Oxidation of iron. So definitely this will converted. There will be the rusting of iron. So simply, if iron sheet is available and that is not protected against the corrosion, so definitely that will corrode. The rust will be there in an iron sheet, and presently, whatever in the monsoon season, uh, moisture is more and more, so the corrosion will be more and more in case of the iron rusting. So that is the iron undergo the process of the oxidation. So iron undergo the process iron 0 oxidation state to plus 2 oxidation state. So in case of iron plus 2, 2 electrons are removed, and the process the de-electronation. So de-electronation, the process itself is the oxidation. So iron undergo the process of the oxidation. Even the other metal also undergo the process of the oxidation. What about the sodium? Sodium is converted into sodium plus 1. So that will definitely the de-electronation. Copper plus 2, the de-electronation. So certainly oxidation is the most relevant answer and most fundamental chemistry, most fundamentally relevant with the chemicals. So we have to know about what are the chemistry, what is the chemistry, and what are the chemicals involved in that alloys. Why we are using the alloy? Because of the protection against that particular metal. So copper is added, the zinc. Certainly, the alloy is formed, and that is the metal, that is the brass is formed. So why brass is there? There, because instead of copper, so copper undergo the process of the destruction. So copper undergo the process of destruction because of the environmental conditions. So what are those environmental conditions? Moisture is present in the atmosphere, in the environment. Oxygen is present in the environment. The carbon dioxide is present in the environment, and certain corrosive gases are also present. How we get the corrosive gases? Because of the petroleum or whatever uh, uh, the fossil fuels, and examples are the that is that are the petrol and diesel. So petrol and diesel undergo the process of the combustion, and the amount of sulfur contained in the petrol and diesel is converted into the sulfur oxides. So sulfur oxides are also the corrosive in nature. So certain, and that can also damage whatever the concern. All of you are well known about the acid rain. So in case of the acid rain, certain nitrogen containing compounds after combustion. Where is the combustion? All of you know about the different electricity generation, thermal power plants where the coal is used, and as well as our petrol, diesel, the combustion of petrol, diesel, where the nitrogen in the atmosphere, and definitely that will produce the nitrogen oxides. So nitrogen oxides are also the example of the corrosive gases. So in the environment, many of the corrosive gases are available. Even oxygen that the help into the oxidation process. I have earlier discussed oxidation is also the corrosion. So how we can get the rid of about how we can improve the corrosion resistivity. So that is in this following chapter, following concerned, and we will discuss about that how the corrosion can be protected. This is all of you well known about the alloys, metals and alloys. One of the example of iron, number of alloys. You know, stainless steel. So stainless steel is because of the corrosion resistance. So that alloying is the one of the protection against the corrosion. Even we can say certain metals and alloys are also protected against the corrosion, and those are the simple one. The paints, the coating, different types of coating, metallic coating, galvanization, tinning, all those are the process of the protection against the corrosion. So why? Because the most of the economy of the world, and that economy of world, and here the major metals are substituted. That is because of the corrosion in those particular metals. So we have to discuss about how the corrosion can be protected. So let's I have given one of the example. This one is the chemical reaction at a metal and environment interface. So I have discussed about how these metals reacts with the environmental condition. So what are those? In this particular case, we have to see uh, the corrosion as a chemical reaction at a metal and the surroundings, environment. I have discussed about the various corrosive gases. So various corrosive gases, and those are the sulfur oxide, the nitrogen oxide, even the chlorine, even some of the other halogens, even the some of the acids which are present in the environment, and definitely direct react with the metal. So here are the some of the other metals, whatever those are also specific, and the sodium, potassium, calcium, barium, aluminium, and the magnesium, copper, nickel, cobalt, silver. What about the gold and platinum? You can see the periodic table, and periodic table can explain all those the metals and alloys, metals arranged in the arrangement of in the periodic table. The alkali metal from left to right. So here the left side, the group number one, alkali metals, alkaline earth metals. Then we have the transition metals. Then the p block elements. Case of the p block elements, certain metals are also there. So aluminum, the metal, the p block elements. So that can also undergo the process of the corrosion. The rusting, that is whatever that rust is related with the iron. All of you can know about that. How many number of alloys of irons are available in the present context of the technology? Present context of the technology, various systems, whatever the transportation system, whatever the infrastructure system, whatever the electronics gadgets. So iron ingots alloys have a very great opportunity. So alloys of iron, the most one, and those called the simply steel. Steel, stainless steel. Number of steels are there. Hard steel, whatever the steels are there. The tooling mechanism, the simple drivers, screwdriver, simple whatever the drilling machine. So drilling machine having the particular rod. So even the cutters, marble cutting, the metal cuttings. So how we get that particular alloys? So that is because of the so addition of some other metals into this. Iron, the plate carbon steel, that is the silicon and carbon are added. So certain other elements are added into the R. Then we have the stainless steel, certainly. So alloying is also one of the phenomena by which the corrosion can be protected. So here the simple way reaction and changes in the metal into the product. So decay of that particular metal, the copper in presence of moisture, in presence of carbon dioxide, this will converted into the copper hydroxide and then copper carbonate. So all of you can know about that. That if suppose you have the copper utensils of you have the copper metal, so certainly that particular copper itself is deteriorated and converted into the greenish material, and that greenish material is the copper compound. Whatever that may be, the copper hydroxide, that may be the copper carbonate. In case of the iron, we get the destructed product. So iron itself undergo the process of the corrosion, undergo the process of the rusting, undergo the process of the oxidation. What happens? Iron will be converted into iron oxide, and that is the rusting product. So here the reaction occur, direct reaction occur. However, certain other things are also available. The electrochemistry, and that relates with the battery. So batteries have also, so that is also the type of the corrosion. So here we can say the simply the corrosion, the metal destroyed, and the product are. So in between metal and product, what happened? Metals are come down, and where go? That product is formed. Iron, where go? Iron hydroxide is formed. Iron oxide is formed. Copper, where go? Copper carbonate is formed. Hello, we are well known about the silver, silver coins. So silver, whatever the lustrous, whatever the very beautiful silver coins, but in the environment, oxygen is present. So what happened? Silver undergo the process of the oxidation because the oxygen is present. So because of that a particular oxygen, silver undergo the process of the rusting, and there the silver oxide black coating is formed over the coins. So if those coins are protected, then definitely they under the process of the alloying. This is the technique. Protection against the corrosion. Then that particular coin remain as such. If that is the only the silver, so certainly that undergo the process of the corrosion and that silver oxide coating will be there. But in case of the gold and platinum, those are the passive metal. Reactivity is less as compared to other metals. So more reactive metals are where? All of you well known about where are those more active metals. More active metals in the periodic table, alkali metals. From top to down, sodium, potassium, rubidium. So, sodium and potassium, I think all of you know about the sodium. Sodium is not openly kept in openly, cannot remain openly. Why? That is reactive metal. That can react with the environmental conditions. What happened? We are putting those sodium in the kerosene oil, in the paraffin oil, inactive solvent. So those inactive, whatever that, in case of the paraffin oil or the kerosene oil, those does not react with the sodium. But when sodium is outside, if that is kept openly, so that will be. Sodium itself is converted into the sodium oxide, sodium hydroxide. That depends on the environmental condition. Similarly, potassium. So potassium, if suppose we have to put on the paper, so paper will be burned. So what happens? Potassium is the metal. So that is the corrosion, because that particular potassium itself is converted into potassium oxide, potassium hydroxide, whatever. So all of these, we have the barium, we have the calcium, we have the aluminium, we have the magnesium rubber, but those are also so environmental conditions are important, relevant. Which the most one, oxygen itself is very responsible, and oxygen is responsible for the process of the oxidation. So let's say we have to continue for the other part. So gold and platinum, those are the passive in the nature. So now the next we have to see, this is the simple one. So what happened? Iron, water, moisture. In moisture, the today whatever present day the monsoon season is there. So moisture, relative humidity in the environment is poor in case of the monsoon season. In the cases where the mostly are in the coastal area. So coastal area, the relative humidity is more. So in case of the coastal area, for example, in India, the coastal area, the Mumbai, the Chennai, in those particular area, the corrosion will be more because of the presence of the moisture. So relative humidity in coastal area is high as compared with the inner areas. So that is the so iron undergo the process of the rusting and the formation of the iron oxide. So if suppose 10 gram of iron is there, and here the iron oxide the product is formed. So out of 10 gram, if 7 gram remain in the iron, and rest is in the form of the iron oxide. So where go? That is the destruction. That is the decay of that particular iron sheet, decay of that particular iron rod. So in infrastructure, we have using the TMT rod. Specific rods are used for the construction work. Even the so many infrastructure works like railway overbridge, whatever the river bridge, railway, uh, whatever the different infrastructure, high skyscraper buildings. So their metal itself is the in the form of the iron. So what happened? This process is called the rusting. So metal, but what happened? If suppose we have to back to the reverse from metal oxide to metal, all of you know about that. The different ores and mineral undergo the process of the metallurgy. So metallurgy is the process where the reduction occur. So metallurgy and corrosion both are reversed with each other. In case of the metallurgy, the metal oxide is converted into the metal. So therefore, but when metal is there, so the metal undergo the interaction with the environmental conditions, and that is the oxidation. Whatever we have already discussed about these phenomena, introduction, definition of corrosion already discussed, the approach of corrosion, the significant value we have already discussed, whatever the value significant, the life of the machine can be increased with the understanding of the corrosion and with the understanding the things of the protection against the corrosion. Without the chemistry, we cannot enhance the life of any of the machine. Even if suppose mobile having the certain uh, material parts, certain metallic and certain alloying, so those are also relevant with the corrosion. Significance value on the corrosion itself is the chemical reaction. Then we have the theories of corrosion, but the fundamental behind this corrosion phenomena. So we must have to know about the basic of the chemistry to understand that. That is important issue. Why that is important issue? because the role of chemistry is important in any of that. So let's we have to continue the where the classification of corrosion process, the different corrosion process are also there. So direct corrosion, indirect corrosion, whatever that is the theory of the corrosion here. The two different theories are there. The first one is the chemical theory. This one is the simple reaction of A with reaction of B. The product itself, that is the consumption of the A. So A will be decay, A will be deteriorated. So that particular the theory itself is the chemical. That is also the dry corrosion because the reaction of the chemicals. So that is so here one most important concern at this present technology, that is the electric vehicle. What about the fundamental of electric vehicle? How they run? There is the most important concern is the chemistry. Most important concern is the use of the chemicals in the electric vehicle. Not specific that particular vehicle is there, but there the battery is the important concern. Why battery is important concern? Anyone? Because battery itself is related. Battery is concerned with the electrochemical theory, and battery is also concerned with the corrosion. That is the indirect corrosion. So this is two type of corrosion. But we have one direct, direct attack. So what happened? Direct attack, then something dead. For example, in a war between the two countries, so what happened? They attack direct. So persons are died. So direct corrosion is like that. So what happened to the person? Persons are died. The loss of the metal. And in the another case, the indirect attack. Whatever those indirect means, for example, spreading of different biochemical weapons. So if those are there, so even certain pollutants are there and which are going our inside, and that is the slow poison. If direct poison, that can kill this immediately, but slow poison, for example, different pollutants present in the water, those are the slow poison. So slow poison attacks slowly. So electrochemical corrosion is like a slow, whereas the chemical corrosion is the direct attack. So in case of the direct attack, the loss of the metal. So how we can get the protection against the corrosion? This is the important. This is the security of the country. How? If we have the no army, whatever, we have no security at the border. So similarly, those metals must be secured with the protection, protective coating, whatever the other designing of the protection. Simple, the protective coatings, the paints are the most important. Coatings with different galvanization, tinning, metallic coating. You have the chrome plating, protection against the corrosion. So direct attack and indirect. So indirect theory that is the electrochemical theory. That is the important concern in the present context of the battery system. So batteries, all of you know that direct current, anode and cathode. So anode having the oxidation. So that is the corrosion. We simply the chemistry oxidation, the corrosion. In electrochemical cell, the anode position where losses of the metal. So that is the electrochemistry, that is the battery and the present context of the advanced technology. So that can be solved with the help of the chemicals, with the help of the chemistry. We have the rechargeable batteries. We are using the so many whatever the laptop, whatever the mobile. we are charging that. So that is also the issue of the corrosive phenomena, the issue of the electrochemical theory phenomena. Here, one most important thing, and that is the electrode potentials are responsible. So we have to know about the different metals and their electrode potential, whatever the reductive potential, whatever the oxidative potential. Reductive potential means the reduction. So what about the reduction? Electron is added. De-electronation, the opposite of that. So that electrode potential, reductive electrode potential, oxidative electrode. So what happened? Copper is converted into the copper plus 2. So that is the oxidation. If copper plus 2 is converted into the copper, the reduction. So reduction and oxidative, that is the particular opposite to each other. So that is electrode potential is also one of the responsible. And so here we have to see electrode theories of corrosion already discussed. Electro Now the chemical theory, this one is the direct corrosion, dry corrosion. This occurs in the absence of the aqueous environment. Whatever there may be. What happens? If corrosive gases are there, I have given the only simple example, and that is the hydrochloric acid. Where in our houses, the hydrochloric acid, that one is the toilet acid, that is the HCl, and HCl is available in the ample amount, and that toilet cleaner, the hydrochloric acid, the namak ka tejab, that is used. So in case of the namak ka tejab, in case of the hydrochloric acid, hydrogen chloride gas is liberated continuously. So where goes? So the reaction of a metal with hydrogen chloride. So what happens? The metal will be destroyed. So there are certain other corrosive gases are available in the environment. So dry corrosion occurs in the absence of aqueous environment, and this is usually in presence of gases and certain vapors. For example, chlorine gas, and if a tin is there, so tin chloride will be formed, and tin chloride itself is the volatile. So certainly we have can say that particular, and that usually in the presence of the gases and vapors, and mainly at high temperature. So this one is the chemical theory, and whatever the electrochemical theory we have already discussed, that is in the form of the different batteries, where the in case of the electrochemical theory, the use of the whatever the electrodes, that is the anode and cathode. So anode and cathode, here at the anode corrosion occur, at the anode whatever that the oxidation occurs. So let's say we have to continue for that, and dry corrosion. Now we have the protection. So which one? Metals and alloys, how these can be protected against the corrosion. So here, if suppose we have pure form of the metal that have the less attack of the other. If suppose there is the purity in the metals, so one of the protection against corrosion is the protection against the corrosion. That is the pure metal. If we can say that purity of the metal is which one? 99.9%, 99.99%, 99.999 and purity. However, those pure metals are more costly, but that those does not undergo the process of the corrosion, or if they occurs but little corrosion is there. So whatever we can say, this is one of the technique, the metallic coating. All of you know about the galvanization, galvanic protection. Galvanic means the galvanization itself is coating of iron over the coating of zinc over the iron, galvanized iron. All of you know about the GI sheets, GI pipe, galvanized iron pipe, as well as the tin coating. So that process is called the tinning process. So tinning and galvanization, those are the example of the metallic coating. All of you are well known about that electroplating that can be also use electrolas plating. Those are also other way. But here the simply the iron, the rod, iron sheets, and those are passed. So first of all, the technique in galvanization, those are then cleaned and then washed, then dried, and then the molten zinc. So the zinc is melted in the form of the molten, and then the tubes or the sheets are passed through the molten zinc, and this process is the galvanization. This is the part of the metallic coating. Here, the zinc is coated over the iron, and that can be specified with the electrode potential. So that is whatever the electrode potential is responsible to get the which metal is used for specific technique. Here also the tin coating is also there. So that is process the metallic is the tinning. So tinning are now this one is the most important one, and that is the electrochemical protection. So how we can get the question is there where I have already discussed that oxidation occurs where the anode. So here the electrochemical protection are the one of the thing is the impressed current cathodic protection method. Impressive the current and cathodic protection. The another is the anodic sacrificial anodic protection. What happened? The both are the reverse one. One side against the current. Another current is there, but anode is sacrifice. So when we have to talk about the iron, so iron itself in the buildings, so that have the anodic behavior, and definitely iron undergo the process of the oxidation. But in case of the sacrificial anodic protection, where if certain metals which have correlates with the iron electrode potential and those metals are put it on the anode, those become the anode. So that is the specified with the help of the electrode potential. So here we have one more thing is the direct also called is the wet corrosion. Wet corrosion occurs in the presence of so why this here I can mention the electrochemical protection. So in this particular we have to understand that water and oxygen electrodes are formed and certain anode and cathodes are formed. This is whatever the I have earlier discussed the direct and indirect. That is indirect is also called the wet corrosion. So in case of the wet corrosion, uh, because of in the presence of water and moisture, electrodes are formed. So at anode, corrosion occurs in case of the iron. So if suppose that particular iron is openly present, and if electrode is there, electrode is formed because of the oxidation. Iron undergo the process of the oxidation, so iron plus two is will be there, and certainly that particular area is electrode is formed, and here is the impressed current cathodic protection. This is the important one. So here this is the electrochemical protection. Impressed current cathodic protection method. So what happened here? All of you have, this is one is the cathodic protection unit and anode bed. So here reverse of the impressed current is passed on. So therefore, that particular and is metal can be uh, protected by use of the now the sacrificial anodic protection. This one here the anode is sacrificed. Whatever the thing is there, all okay well known about that the oxidation occurs at the anode or whatever I have discussed here. The anode and cathode. So at anode oxidation at anode the so here the use of the electrode potential. Here, the application of the electrochemistry. And with the electrochemistry help, here, if iron object in our building, in the river bridge, iron rods are used, and those are connected with the sacrificial anode. So here we can use the magnesium. So what happened? The magnesium become anodes, but that must be linked with each other. So if so, what happened? Instead of iron, the magnesium will be detonated. So magnesium pieces, magnesium metal is capped, and that is bounded, that is linked with the iron rods. So in this case, sacrificial. What is the sacrifice anode? Who sacrifice the magnesium instead of iron? If those are not linked here, so anode will be protected. And where the protection is use of the sacrificial metal. So here we are using the magnesium. So magnesium connected with the whole of the object whatever the river bridge, and here the river bridge different rods, iron rods are there, and those iron rods are connected with the so this is the so protective current will be observed. Now there are the certain questions, corrosion of the metal involved. What are the physical reaction? Corrosion. Is there any physical methods? Chemical reaction occurs. How? The chemical itself, the react with the, in case of the electrochemical, also the part of the chemicals. So the answer will be the chemical. The next following equation is related to the corrosion. This is well known, and this is the Faraday's equation. So, in case of the Faraday equation, how the deposition of when current is passed. Here also the current, whatever we have already discussed in the sacrificial, and here the current is there. So deposition of that particular electrode, that is concerned with the Faraday's equation. And next is which uh, following factor plays a vital role in corrosion process. The answer is the solute concentration and the temperature. All of you know about the coastal area. For example, in the Mumbai, in the Chennai, and other places where the sea is there, coastal is there. So the solute concentration. So in case of the sea water, the solute itself, the saline water. So as we compare that with the desert area, so in case of the desert area, there is no seawater. So in presence of saline water, in presence of seawater, the solute concentrations are increased in that particular area, as well as the temperature. So both plays important role in the, now the which of the following can be used for the cathodic protection. The answer is the instead of whatever we have earlier discussed about the here the process, the protection. Here also I have given the example of the magnesium. So instead of magnesium, we can also use the aluminum, cadmium, copper, whatever the either not. So answer itself is the aluminum because of the cathodic protection. So whatever we can say, this form of uh, corrosion occurs due to the uniform, the galvanic. Here the answer is the intergranular or whatever the stress. So this form of corrosion occurs due to the concentration difference in a component, that is the intergranular. So whatever I can mention that here I have given value additions in the protection against the corrosion. Here also you can say the value additions in the different technologies, and those can be because of the uh, additions. So here galvanic, intergranular, stress, uniform. So that is depends on the difference of the component. So now I conclude with the repetition, with the summary. and whatever the different protection against the corrosion. So I have discussed different theories by which we can explain what is the corrosion and what and can get the rid of corrosion with the help of different techniques. The protection. So protection against the corrosion. So there are the mainly the metallic coating, and in case of the metallic coating, the metal is coated over the other metal. So that may be the tinning. The tin is coated over the iron sheet. So tin containers, all of you well known, and others may be whatever that may be the galvanization. So galvanization, the coating of zinc over the metal, and certainly there also the electrochemical protection. And in case of the electrochemical protection, the electrochemistry is involved. I think all of you are well known about the different batteries, whatever those may be the dry batteries, whatever the maybe the wet batteries. So different batteries available, and most of the technology concerned with the batteries involvement, whatever the electric vehicle, whatever the laptop, whatever the mobile. So all those are concerned with the electrochemistry. And electrochemistry involved here for the protection against the corrosion, and this can be specified with the help of the so here I think that particular information must be relevant to all of you, and I also suppose that you get more in relevant information regarding the protection against the corrosion. So fundamentally, here lots of discussion occurs. Whole of periodic also discuss, and the whatever the concentration, different saline water, those are also important. So reaction conditions. The most one is the environment, whatever that particular environmental conditions are important. So all about this. Anyone have the specific queries, then he or she can ask me on my mobile number or whatever my email ID. So where I can give the answer. So those are available in the organization, whatever the Swiss Gambia University organization. I'm here. So thanks for all. Any of the query, then you can ask me. And okay, so I suppose you have taken lots of patience for listening, and also like the videos for me as well as for the organization. And if any of the relevant information you want, then you can contact me. Okay, all the best.